Hey guys, welcome to another live stream. Let's turn down that music a little bit. There we go. So, another live stream today. I didn't intend on doing one, but my ultra craptastic video software Vegas Pro, well, I spent like a day or so editing, and then I was like, okay, let's do a test render, and then do some corrections, and then do a final pass. And then I spent 2 days staying up till 6 a.m. in the morning trying to get the stupid piece-ass crap software to render my video. And it just crashes and hangs and all kinds of crap happens. So, yeah, that's not done. So, here's another live stream. Little quiet there. Okay, sure. We can fix that. Thank you, Tom. Let's just move myself closer. Yeah, Yako, I've looked at DaVinci Resolve before, and I was already... Oh, that's a bit hot. There we go. And I was already thinking, okay, at some point, but I started thinking about this 2 years ago, when I have a little bit of downtime, I'll learn everything, how I use Vegas Pro in DaVinci, and then I can move my workflow and templates and everything, standardized keyboard shortcuts and everything I have in Vegas Pro, and I can learn to do that in DaVinci. But in the end, making the videos and releasing them is more important than learning how video editing software works. So between making boards and designs and guiding production and trying to keep it in stock and support for that and making new stuff, the secret of this stream will be the biggest one of this year. So tell your friends to be there at the end. Anyway, making all that stuff, it takes a lot of time. And I can't spend the time messing about learning new video production software if I just want to make videos to release. But I think I'm finally broken, and I just spent like 30 hours trying to get a single video rendered, and I'm done. I'm done. If I make a somewhat fun project, and I spend a day editing on it, which is fine, but then I can't get it out of the software, basically. I was so pissed off today. I mean, you don't even want to know. So, anyway, today we're going to do a fun topic because I felt like doing something fun, and that's, taking a look at 2 power banks I've received. They haven't even gone through Quinbox yet, but hey, since we're here, I guess they won't. And let's see if we, can stress them to the max, and maybe they'll explode. Probably not, but you never know. World tour. Well, I am going to the US in a few weeks, actually. That's actually why I'm trying to stock up on videos, but then my video craptastic editing software prevents that. I have a video with a ton of photos set on my drive waiting to be processed. Oh, okay. And, I do like live streaming. That's true, Jeff. I do enjoy the live streaming. That's why I decided, okay, from anything I can do at this point, let's just live stream, hang out with the guys, test a little bit of hardware, share the secrets, the big secret for this year, and, maybe they'll cheer me up a little bit. So, let's have a drink, because, this time I'm going for Fanta Lemon, because I really like that one. It's nice. It's not focusing at all. Focus on this. There we go. Fanta Lemon. Oh, no sugar. But I do also have 2 Cokes. Don't worry about that. Coke Vanilla and Coke Cherry. So, those are nice too. Yeah, true. I mean, at some point, I'll admit defeat. No, actually I don't. I want to get that video rendered, but then I'm gonna think very hard about ever making another video in that software. It's kind of, man, people keep asking me when there's going to be another IP camera video. I actually stopped doing those videos because the last one I made, I spent weeks on trying to get it rendered in multiple sections and joining that together again, but I couldn't get it to work right. I just couldn't get the video out of the software. I spent days editing it, and I'm just done. It's just, that's why I stopped doing IP camera videos, because it's just, I put in a lot of work and then there's no result. So yeah. No, I was using Vegas Pro. I've been using Vegas Pro for the last 5 years, and I really like the editing workflow. It allows me to edit very fast, and editing has mostly become stable now. I'm not too worried about crashes of the application or the GUI itself. Generally, I can work with that, and if it crashes, I only lose a few minutes, so I can resume there. It does get dog slow if you have like 6 or 7 timelines and some generated graphics and text and stuff like that, but other than that, it's pretty okay. But if I can't get my videos rendered anymore, yeah. So yeah. So I'm going to look at DaVinci Resolve. Hopefully, that is not as craptastic as this has stayed over the past few years. And I mean, I paid $1,000 in total for this stupid video software. DaVinci Resolve is free and powerful. No need a good screen to be able to edit properly, but you need... I have a 48-inch 4K monitor, so I have a good screen. Good evening, Michael Knowles. How is the music volume? Not too overpowering? It's kind of hard to judge on my end sometimes. Patrick Reinhardt is here. Salute to you. Music to voice ratio is perfect. Nice. I like that. Well, let's just get into it. We're going to do a relaxed stream today. I've been hot and bothered all day long, so we're just going to have a little bit of fun. And, well, as the title said, I bought 2 power banks. Let's switch to the top-down view. And these are both from AliExpress. The links are in the video description. And it's a AOHI. AOHI. Okay. MagCube 30,000 milliamp hours. That might cause a problem or not, because I'm not sure you're allowed to take this on a plane. But the rules are kind of vague. So, well, actually, everything I have from Blackmagic, Adam, we're just going to do random stuff today. The capture card I have here is a quad HDMI recorder from Blackmagic. That's working great. I've never had an issue with that. It works every time. And I have like 1, 2, sometimes 3 capture sources, or 4 even, with a monitor and, you know, capturing from a PC HDMI. So in that sense, the $500 quad 4K HDMI capture card for me has worked great. So I'm willing to give Blackmagic a chance in that sense. So, yeah, MagCube, 30,000 milliamp hours. And as I said, it's 108... there we go. It's 108 watt hours. Now, I've tried looking up on airlines and stuff like that if you're allowed to take that on a plane. And basically, if it's in a laptop or in another product, you're not allowed to take it. But if it's a spare battery you're allowed to go up to 160 watt hours. But is a power bank a spare battery? In a sense it is. I mean, and batteries have electronics in them now anyway, so what is really a battery? Yeah, I don't know. So that's going to be interesting. Now, spec-wise, I guess we can look at specs. So 3.6 volt, 30,000 milliamp hours. I believe. Oh yeah, rated capacity is 18,000 milliamp hours at 5 volt. That is very important to remember. When selecting a power bank, they will always shout big numbers, but those are the 3.6 or 3.7 volt numbers. So the actual capacity at 5 volt is a lot lower. And I like that they actually name it on the box. If you draw a 5 volt 3 amp, you get 18,000 milliamp hours. That's very nice to have on the box. Most manufacturers will not tell you this. They'll say 20,000 milliamp hour battery, but in the end, you're able to draw maybe 12,000 milliamp out at 5 volt. So, yeah. Well, no, it's about the size, Raspy. If it's above 99 watt hours, I know it's not allowed to be in your laptop. But I'm not sure it's not allowed to be in a power bank. And well, this is kind of why I got these power banks. These are able to provide 3 to 21 volts at 5 amps, so 100 watt output. So yeah, this is the AOHI MagCube 30,000 PD 2-port 100 watt. Okay, and then we have this Blade series from my favorite company, Baseus. Oh, and it's still in the packaging because, well, this was supposed to go through a Quinn box at some point, but, well, you're here now, so let's do it. Let's get this thing out. Oh, I should get my unboxing tool, huh? Where is it? Oh, here it is. Oh, there we go. Let's try and hook in here. Okay, I'm just gonna cut it. There we go. Sounds Dutch. No, it's AliExpress. What else did you expect? Okay. Let's take a look at this box here. Ooh. It's very fancy. Is this one of the... Oh, okay, we have specs. Let's take a look at the specs before opening it. So these are in Chinese, so I'll put those behind the chat. Oh, okay, this one does it also. So capacity, 5,000 milliamp hours at 14.8 volts. So instead of having 3.6 volt lithium cells, this one seems to have a different battery configuration at 14.8 volts. But it ends up being 74 watt hours. So about 2/3 of the other one. And rated capacity at 5 volts 3 amp is 12,000 milliamp hour, and the other one was 18,000. So the other one is about 1/3 bigger or something like that. This one has 2 Type-C ports, which can do input. It can do input. Sorry. It can do input up to 20 volt, 3.25 amps. So that's 65 watt. While this guy can do in 5 volt, 100 watt. So 5 amps, 20 volt, 5 amps. Interesting. Yeah, probably, Adam. Yeah. Or just different types of batteries, because there's no 18650 cells in here, but we'll see that in a minute. Okay, so it can do 20 volt 5 amp. Combined outputs. Oh, it can do 65 watt plus 30 watt. Nice. That's okay. 5 volt total output, 9 amps. That's pretty good. Okay, let's take a look at this one first. It's one of those, you have to shake it to get it out box. Oh, oh wait, I'm still zoomed in. Sorry. Okay. It's a nice box. There is a little USB-C cable here. USB-C to USB-C. Doesn't say... Oh yeah, it says 100 watt here on the sleeve. So that's a 5 amp cable. Good. Oh. Okay. Okay, well, whatever. There we go. So you get a little sticker, some Baseus. You get a little, I don't know, card, a warranty card, okay. And then you get a little booklet. How awesome. But you also get a little pouch. I like the pouch. That's nice. So, as you can see, this is... Oh, I kind of wrecked the packaging experience. I know that's not supposed to how it's supposed to go, but, you know... So, as you can see, this does not have 18650 cells because it's definitely not thick enough for that. Okay, let's move the box out of the way again. Yeah, they're very different form factors. That's kind of why I also bought them both. Oh, let's get the sticker off, shall we? Oh. So yeah, this one is very flat, but if you have a backpack, you often have pouches which will accommodate a nice and flat, battery pack. And this one also has a screen, I believe. There's an on button here. Oh, 80. Okay, it's not flickering in real life, but that's a nice display, actually. Pop bank pouch cells instead of cans. Yeah, that's why I said it has a different configuration in it. Okay, let's unpack the other one too. Let's take a look at that one. Seems to be portable CD player size. Yeah, that's about right, I'd say. Not like anyone still uses that. Yeah, we just gave away our age. Again, nice packaging. So, we probably get another cable, let's think. Okay, if the cable is in a box like this, it really doesn't need extra plastic sleeving around it. I don't like that. Okay, well, whatever. Oh, that's probably another 100 watt cable. Or 5 amp cable, but yep, sure. Cool. And the power bank. Oh, this is a chunky boy. Wow, that's heavy. Okay, yeah, well, we got a little booklet. Start guide. Well, I think I can figure it out. I do generally keep the boxes around for a little while. Okay, MagCube P30. There's a button here. Okay, it's 75% full. And it has a in and out port here for USB-C. And then an USB-A out port. And that's basically everything that's on here. It supposedly has all the certifications. That's good. Yeah, I don't get that either, Earth Gamer XE. I mean, if it's in a carton box, it really doesn't need another layer of plastic. Come on. I mean, yeah. Cool. So, are we just gonna try and, draw the maximum amount instantly? What are we gonna do with it? Let's see how much input current they take for charging it. Now, if you watched the latest Quinboxed, you saw me unbox these guys. These are two USB-C power bricks that, well, this one says it on there clearly. This one does 240 watts, and I believe this one does 220 or 200 watts or something like that. No, I'm not gonna take hours, Patrick. So this one can do USB-C 100 watt on these, and this one actually says it on here 100, 100, and 100. So I really like this one because it gives you lots of ports. And it's actually smaller. Okay, these have those plugs. I have been testing these off camera for a while already, and I generally like them both. They're GaN-based chargers, so they're very efficient. And well, I've been charging my laptop and stuff like that with them, and that's been working great. So let's I don't know, let's use this one. See how that does. Let's give it some power. Sure. Okay. Well, it has a nice green light. Not much to be said about that. Let's get a tester. I use these RD-Tech testers. I have 2 of them, and those are rated for up to 20 volt 5 amp, so that's good. And I don't know, let's plug it into the power supply, because we're partially testing the power supply too. Nothing happens because there's no load. Let's get a short Baseus cable, which I know is good. I've tested those before. Okay. So we're going to have meters everywhere, because the cable actually has a meter of its own. And I don't know, let's just plug this in like that. Let's put this upright and then plug this in and see what happens. Okay. My power cord isn't long enough. Wait, let me change that. Okay, power. Yes, let's see what happens here. So we're getting... It's ramping up. It's ramping up. 65, 70, 80, 90, 99.6. Damn. That's pretty good. Well, you do have to remember, this is measuring the output, and of course what will arrive at the device will likely be slightly lower. So the plug in the device is measuring 97 watts, and this is measuring 99 watts. I can imagine a little bit of voltage getting lost there, you know, over the cable. It's not a long cable, it's half a meter. But first test confirms this guy will do 100 watts on the input to charge it. And it's already 3/4 filled instead of fully filled. So, yeah. Yeah, I do like the light on there, but this one's a bit bright. But I guess you can always put a little bit of tape over it or something like that. So, you know. But this confirms this power brick, which I kind of already knew, will actually deliver the 20 volts and 5 amp output, no problem. And this power bank will take it as input. That's good. Oh, and the plug is warm. Okay. Then let's do the same test, but with the other guy. Which is the in port. In and out. Oh, they're both in and out. Okay, so there's 2 USB-C ports here and 2 USB-A ports, and they're both in and out. Okay, let's try one. Oh, what's this? Oh, you can't see. Nice! You don't need all these measurement plugs anymore. It says it right here. So let's compare 20.08, 3.3 amps. So this is doing 66 watts. Cool. And we're at 80% charge. and it's getting 19 volts with 3.3 amps, and charging time left is about 11 minutes, it says. Okay. Yeah. That's an awesome little display there. Cool. So let's try in 2. Sure, it ramps up to kind of the same thing. Oh, actually, it's a little... Oh, no, okay. Display is adjusting. Exactly, Tom. This one can only do 100 watt output, but it can't do 100 watt input. But that is according to the specifications. Because if I look at the box again, it says input 20 amps, 3.25, 20 volts, 3.25 amps. And well, that is exactly what we're seeing. So that it adheres to the specifications. And I mean, with 65 watt, you can still fill it up pretty quickly. Most power banks actually won't accept more than like 24 to 28 watts. So that's already a good score in my book. But yeah, like we saw, this guy will actually do the full 100 watt. It's a nice ramp up there. It's a good behavior, because, you know, yeah, 100 watt, no problem. Nice. Okay, so we've now determined that we can charge these things with 100 watt or 65 watt, but at least adheres to the specifications. And these are already 3/4 full, so they'll likely do that almost until the end. Generally about 85 to 90%. They'll likely start to ramp down charging speed, but that's fine. You mostly care about that initial fill, so yeah. Oh, how many milliamp hours are the new ones? This one is 30,000 milliamp hours, and this one is 20,000 milliamp hours. Or am I saying that correctly? Well, actually, this one is a bit hard because the batteries aren't 3.6 volts. But this is 74 watt hours, and this is 106 watt hours. So that's a better measurement to show you how much capacity is actually in there. Okay. Now that we have that running, let's build a testing setup. Well, this one uses different kind of cells, Maiko, because it says that the cell voltage is 14.8 volts at 5,000 milliamps. Okay, let's build a testing setup. And let's verify that with the charger, where we can actually draw 20 volts, 5 amps. And I think I can do that using one of my little tester boards here. We have to remove these leads. Oh no, I forgot to get the little extension board, so I have to go looking for it. Oh, that's a good one. Yeah, if you can load and unload from them at the same time. Sure, we'll add that to the tests, EarthGamer. No problem. That's a good question. So I need to get a little load board. Oh wait, I have one here. Yes. So these testers come with a little board that have a USB-C plug right here, so that you can use these testers with the USB-C equipment. Now it won't do any triggering, but it will function as the load. But we can have our little measurement device here trigger, and then this be the load. The White Rose. Hello, Andres. Enjoying the streaming. Oh, Gabriel. Hey there. Nice. So let's screw that in. I really love these testers. You got such a MOSFET with a fan on it. Yeah, they're excellent. Okay, that is in there. So in theory, I should... Oh wait, no, let's turn it on. Power adapter... Yes. Okay, let's plug it in, see what it says. Nothing yet. What happens if I start a load? No. Okay. It doesn't identify the load. Maybe I need to switch here. Yeah, okay. So now we're getting 5 volt. And I can do a 100 mil. Let's do half an amp load. Sure. This one works. It's reversed, but can't help that. And, okay. So let's see. I don't know. Let's draw 1 amp. 5 volt. We'll likely be able to do 2 amps. Okay. 3 amps. We're getting half an amp of voltage drop, but there's a measurement device here, and then there's the cable, and there's a measurement device here, and then this little board, and, you know. Can you add the power charger link to check it? You mean this brick here? I think I forgot to add those. Savach, if you're on the Discord server, ask me in the Quinbox channel, and then I'll reply after the stream with the link. So let's see if we can do more than 3 amps. 3.1, 3.2, 3.3, 3.4, 3.5. Nice. Anyway, we weren't testing this charger right now. Sorry. I need to have the this little board do a trigger. Now I need to remember how to do that. I thought it was this way. Maybe not. Let me zoom you in a lot. Okay, so we need to do a trigger because we want to trigger, or we can do a detection. Why is it not working? It seems if this one, maybe one of the buttons is broken. Gladly I have 2. Let's try that. Yeah, see, this one I can go back and forth. Let's hold it. Okay, so of the other one, maybe the button is broken, not sure. And I want to trigger USB PD. Hold it, I think. No. Oh no, I don't want that. Oh well, I can trigger quick charge, but that's not what we're doing here. But it works. So now I can control what the power supply sends out using this little board. But we want USB PD. It says please reinsert. Okay. Right. Okay. Ah, okay. Yeah. So I can select 12 volt, 15 volt, or 20 volt up to 5 amp. It's very hard to hear. Maybe I can zoom in even more. There we go. Oh, that's clear. Yeah, 20 volt, 5 amp. So now we can also see that our load also sees that 20 volt. So let's load it to, I don't know, 4 amps. See if it handles that. And we're currently doing this with the power brick because we want to build a verifiable working test, and then we'll do that with the power adapters. Yeah, I think of the other one, of this one, maybe one of the buttons is broken. I'll have to figure that out. Well, you know, maybe it's just a meter only now. We'll see. Okay, so it's doing 4 amps just fine. And, oh, let's do 5 amps, huh? 5 amps. That's too bad this is reversed. But I think it says 99 watts. Yeah, it does. Okay. 98, 99, yeah. Yeah, and this one's doing 20.15 volts. And we're seeing about 5 amps, that's correct. 19.2 volts. We're getting a little bit of voltage drop. Oh, you've had them fail on several items now. Okay. Anyway, this is still using this AC connected power brick, but we now have a verifiable test that we can actually draw 100 watts over USB-C and trigger the USB-C protocol. That's what we're doing. So let me see if I can exit this. Oh, I can. What? No, I don't want that. Oh, cool. I can exit it while it's running and still get my measurements. Okay, let's end that. Good. Yeah. So, we now have verified this works, right? This one's still cooling down. Let's have it cool down a little bit. Let's start with the Mag Q P30. So initially it sends 5 volt. That's fine. That's correct. It's a bit high, 5.2, but it's okay. Let's first do a detection run. Oh, it's dangerous? Okay. Let's not do a detection run. Oh, it's still doing it. Okay. Yeah, but it's not in the right mode. Maybe we don't want that. Let's not do that. Trigger. Okay. Please reinsert. Okay, and let's get to... Oh, this one actually supports more modes. Come on. You can do it, camera. Oh, come on. Really? Do I have to do it this way? There we go. So this one supports all the modes with 3 amps up to 15 volts, and then it can go 20 volts, 5 amps, but then it can do PPS, and basically PPS means those ranges you see here. It can do those ranges from 3.3 volts to 6 volts with 3 amps, and then from 3.3 volts to 21 volts with 5 amps. Interesting. So that's good. It seems the chip in this charger or this power bank is very versatile. Okay, we're at 20 volts immediately. That's good. Let's hit it with 5 amps. No dabbling around, just hit it. In theory, I should be able to go back now. Yep. And there we go. This power bank is now delivering 20 volts at 5 amps. And the display is off. Let's see. Okay, if we hit the button, the display turns on. Okay, let's keep that running for a minute or two. See how it does. What are we talking about? Oh, the buttons are crap. Yeah. Is that a power brick with a cord towards a base? You mean this guy? It just has a power plug in the back and then ports on the front. But it's one of the chargers I got that can actually do 100 watt USB PD. Oh, you have a USB 32 with a broken one as a power button. Yeah, yeah. So let's wait for a few minutes, but so far this thing seems to be performing just perfectly fine. And I have my laptop here, and it comes with a 90 watt USB-C charger. So that'll be the last test. This is more of a synthetic load, although this does USB-C PD trigger, so anything that will be able to do this will draw this. I mean, what would you consider an unacceptable voltage drop? Well, we're doing 5 amps, so that's pretty high for this type of cable. 1 volt with 20 volts, that is 5% or something like that. That's actually good. This is a good cable. But it really depends, because I also have, for instance, a 2-meter cable here, or a 3-meter cable, which I generally use with my laptop. Yeah, there's always going to be more voltage drop on a longer cable. I mean, but is that a problem? I don't know. Once you start losing like tens of watts, then it's a problem. Okay, well, I'd say this one is passed. This works. So let's try and over-ask it. You know why we're here. So let's go to 5.1 amps. Okay. 5.2. 5.3. And the voltage on the output is slightly dropping. Oh, hold on. Yep. 5.4. 5.5. Oh, no, now it's not liking it. Okay, turned off. So it was able to do 5.4, and then it turned off. That's respectable, as long as it turns off. Let's turn it back on again. Oh, wait, okay, it won't do 5.5 amp draw. So if you overdraw it while turning on, it just turns off. Let's turn it on again with 3.5 amp load. Oh, it doesn't like that either. Okay, turn it on with 1.5 amp load. And that's fine. Of course, I think USB is limited to 3 amps anyway, so that makes sense. So let's try and trigger it again. Please reinsert. Okay, and let's just go to the 5 amp version. Yep, no problem. Does it all the time. Yeah, 105 watt limit, but that's very respectable. That's fine. So the reason you get something like this, if you want to charge your phone as fast as possible, or your tablet or your laptop, because USB-C is on most laptops now. And as I said, later we'll be doing a test with mine, and I know it can take up to 90 watts in. So then you have extra battery capacity for your laptop. So far this thing is doing fine. Nothing is getting really hot or warm. Stability is good. I'm giving this a pass. This thing does 20 volt 5 amp, no problem. So actual 100 watt USB-C PD. Cool. Yeah, I know there's a new USB-C standard coming that will indeed do even more. So I believe 40 volts or maybe even 48. But it'll be a little while before it's here, I think. Now, one of the things I want to test just for fun is how much can it deliver on its 5 volt output. So 5 volt 1 amp, no problem. 5 volt 2 amp, no problem. 5 volt 3 amp, no problem. And, okay, let's 3.5 amps. Okay. Oh, okay. 3.5 amps, that's it. So let's put it back to 3 amp. Turn it back on again. Does that without a problem. Can it then sustain 3.5 amp? Let's try that. Yeah, but cell degradation can be mitigated, Adam, by using multiple cells. So, and the technology in the cells is improving. But with this guy, you can actually see it, that this is the 30,000 milliamp hour version. The 20,000 milliamp version actually only charges at 65 watt. And I believe the 10,000 milliamp version charges even slower than that. Okay, so it seems like it's able to do 3.5 amps, no problem. And immediately once you go above that, it shuts off and it's done. Okay, I really like this thing. It's pretty compact for what it is. I mean, 30,000 milliamp hours is a lot of power. It's heavy. It's certainly heavy. I do like this drink. Yeah, it's nice. The Fanta lemon. Yeah. Yeah, I like this one. Good, good. So, let's do the same tests with the Baseus, and I'll try and get that on the screen so you can also see its screen. So let's use USB-C 1. Oh, wait, no, stop. It didn't like that. It was still set to draw 3 amps, because I have disabled the under voltage lockout. So let's draw 500 milliamps. Okay, it's not turning on. That's fine. It doesn't seem to recognize that I want it to output. Let's turn it on first. And then plug it in. Okay, now it's giving output. Okay, that's good. That's fine. And, okay, let's do it like that for now. Let's just try and trigger that USB PD. Please reinsert. Okay. Okay. I'm just gonna do it like this for now. Yeah, like it's ever gonna focus on that. This one basically has the same range. Oh, no, it doesn't actually. Okay, I'll have to show you. Oh, that's already focused. Nice. So this one can do 5 volt 5 amp, 9 volt 5 amp, 12 volt 5 amp, 15 volt 5 amp, and 20 volt 5 amp. That's actually more than most chargers, because those will only do 3 amp up until 12 volt, I think, or 15 even. And it can do PPS also with 5 volt. Okay. let's set it to 20 volt. And let's go back to the overview screen. Oop. So I still had it set to draw 500 milliamps, and this is an interesting one. It says 20 volt, 0.6 amps, okay, and it can sustain this for 3 hours and 56 minutes. This is not a touchscreen, is it? No. So that's an interesting measurement there, because if we up this, nice. So now it knows, okay, we're doing 20 volts 1.1 amp, and I can do that for 2 hours and 20 minutes. Or 18, 16, 15, let's go a bit fast. 13, 12. Well, it's probably averaging over, you know, a few seconds. So, yeah, there we go. Okay, let's go to 3 amps. Okay, 3 amps, no problem. 4 amps, 5 amps. Yep, 20 volt, 5.2 amps it thinks, while we're only doing an actual 5 amps. That's okay. And it's estimating it can do that for 28 minutes. So, you know, it can decently charge your laptop pretty fast. Hey Neil, well, we're still partying, no worries. I like this display. This display is cool. But, again, it seems to be able to do 5 amp, 20 volt, no problem. 99 watts. Oh, you can't see. 99 watts on that little measurement there. Oh, the UPS style. That's good. We'll do that after we test the laptop. Because I want to do the same test in the same order, and then we'll do the UPS style test. That's a good test, though. Well, this is draining quickly, as you can see. So I'm convinced it'll do this for, you know, as long as it can do it. Let's try and ask more. Okay. Okay. Sure. Oh, it's not liking that. A 2 point... What? What? No. So I'm getting the amps, but the voltage just totally crashed. And if I back off, we get 20 volts again. So this one radically drops in voltage for some reason. What if we continue? 2.7 volts. Oh, it rebooted. Yeah, and my output's gone. And it's not booting because I'm still trying to ask too much. Let's go back to 5 amps. Can I start it up? No, it doesn't like that. Okay, let's turn the tester off. Can I then start it up? Yeah, but now it sees no draw, so it'll probably turn off. So let's go down to 1 amp. Let's start the draw, and then start up the power bank. Or not. Let's try it again. Nope. Nope, it's dead. It's not turning on again. Oh, there it is. Okay. Phew. Okay, it still turns on. Let's plug this in. Okay, yeah, it's starting to provide output power. Good. But it's not doing anything yet. So let's do 1 amp. Okay. Yep, that still works. So just like the other one, I'm also interested in knowing how much it will do at 5 amps or 5 volts. So let's go to 2 amps. Okay, let's go to 3 amps. No problem. Oh. 3.1, 3.2, 3. Oh, okay. This one doesn't seem to be doing. Okay, let's go back to 3 amps. See if we can turn it on. Nope, doesn't want to turn on. Let's unplug it. Okay, that makes it come back. And then if we plug this in. Okay, and it does do something on my PC just disconnected. Am I still here? I think so. Anyway, yeah, so it does do 3 amps, but it doesn't really like doing anything above that because at 3.3 amps it shuts down. Okay, sure. But unplugging and then replugging makes it come back to life, and it immediately does 3 amps again. Cool. So this one is slightly more limited at the 5 volt measure or 5 volt level, but still it does 3 amps, which it should. That's basically what it's rated for, so that's fine. Cool. Oh no, I actually want to test something. Let me trigger USB-C again, or USB-PD, because the USB-PD said it would do 5 amps at 5 volt. So let's see if we trigger USB-C 5 volts. Hey, didn't work. Let's try that again. Please reinsert. Okay. Yeah. Because here it says, oh, no. Now it says 5 volt 3 amp. But even 20 volts says 5 volt 3 amp. What? That's odd. Let's turn this off. Let's reinsert this again. Okay, let's re-enable. Oh, no. Please reinsert. Yeah, it's only saying 3 amp at all the specified. It's not clear enough. There. It's only saying 3 amp instead of 5 amp it said before. Don't know why that is. Oh wait, aren't we're... No, we're still in the same port. Yeah, I don't know. Okay, let's trigger 20 volts. And let's do 5 amp. Oh, it actually doesn't do it. What? You broke it. I don't know. Let's try it again. There we go. Okay. I want to trigger. Please reinsert. Yeah, it's locked to 3 amps now. So if I go to 20 volts, okay, it does still do 20 volts. And let's start a 2 amp load. It has no problem doing a 2 amp load. 2.5. Okay. 3. Okay. Still good. 3.1. 3.2. 3.3. 3.4. And it's dead. What? What's going on? I'm quite certain we did 5 amps just now. I'll try the other port. Oh wait, no, I can't do that. Overheat protection, I guess, but then the USB-C capabilities shouldn't change, should they? Please reinsert. Nope, still locked to 3 amp. I don't know what's going on. What should we do? Can I still do 5 amp with the other one? Oh no, screws are falling out. That's not good. Hold on, my tester needs repairing. Put it in the fridge. Yeah, I don't think so. Yes, hold on. I need these tiny screws. Okay. One more. You're like a kid at Christmas that breaks his toys the first day. Yeah, I know, but somebody has to do it. And I don't mind doing it. Sometimes it's a bit expensive, but other than that. And that way you guys know damn it, what's actually good to buy and what isn't. And I mean, not everyone has the equipment to do it, so... Come on, little screw. Oh! Try and screw it in that one. There we go. Okay. So let's try this guy and see if I can draw 5 amps with that one. Please reinsert. Yeah, 3 amps all the way down to 15 volts and then 5 amps for 20 volts. So let's just do that real quick. 20 volts. Let's hit it with 1.5, 2.5, 3.5, 4.5, 5 amps. Works. Good. Okay. Next. Charger or a power bank. Thanks, Philip. Philip says, here's $5 or €5 for all the equipment broken down in the name of interesting live stream content. Okay, let's go to trigger. Please reinsert. Okay. And now it's back to doing 5 amp on everything again. Okay, it's not ultra clear, but it should be visible. There. Now it says it can do 5 amp on everything again. What? What's going on? That doesn't make sense. Okay, if you can do 5 amp at 5 volt then, let's go to 3 amp. Okay, 3 amp. Yep. Let's go a little bit higher then. Oh, 3.5 amp, and we're at 5 volt, remember. Four amp, 5 volt. 4.5. 5 amp at 5 volt. Yeah, we're getting voltage drop, that's normal. I don't know, man. And now I could even, in theory, hit this little button here. Yep. Now we're at 9 volt. 12 volt. 15 volt. 20 volt. 5 amp all the time. Tester didn't stop. Yeah, the battery says 5.2, 20 volt. Yep. So it's able to do it. It just didn't like doing it anymore. I don't know. Reminds me of that Meanwhile power supply that needed like 15 minutes to rest or something like that. Okay. So we'll do the can it do it while it's charging a little bit in a minute, because I want to do one last official test, and that is basically let's disconnect this, reconnect it. Okay. Basically, can it charge my laptop? Because that's why I got this thing. So my laptop has 2 USB-C ports. They can both be used for charging. And, well, let's just plug it in and see what happens. Okay, it's currently giving 5 volt at 1.3 amps. Now the laptop, because I don't think, wait, no. Hold on. I need to flip a switch here. There we go. Yeah, okay. So you either, this meter, you can set it to do PD and stuff yourself, or the device that is hooked up to it can ask for it. And it was set to do it itself. So I flipped the switch, and now the PD question of the remote device, so in this case my laptop, is coming through and through the meter. Okay, it's doing 20 volts, 3 amps. Okay. But is that now because this thing is locked again, or because my laptop isn't asking more? Yeah, I know, Philip, I know. Okay, let's see what happens if we hook up the other power bank. Hello? It's drawing 5 volt. Let me flip that switch again. Oh wait, maybe I flipped the switch on accident. No. What? I don't know, man. Okay, I'm gonna try and use that wall socket again, or the wall charger. Let's see here. Plug in. 20 volts. And there we go. 20 volts, 4.4 amps, 88 watts. 87. No, I discharged the battery to 40%, Tom. So I kind of got ahead of that. So Volt Charger says you can have whatever you want. If you want 20 volts, 4.8 amps, 83 watts, no problem. Okay, so that works. Okay, that works. Let's try this guy again. 5 volts. Oh. It's turning on and off. Okay, I'm gonna try without the meter in between real quick. Keeps turning on and off, you see that? It's not liking it. Let's try the other port. It's either the battery or my laptop that doesn't like it. Yes, 7 watts. I mean, that's useless. Okay, just to be sure, let's try a different cable. This is the cable I often use with my laptop. But then I have to use the plug, because otherwise I don't know what's going on. Yeah, but it should work with a generic 5 amp rated USB-C PD cable. I mean, it works with all the other stuff. But okay. Nope. Turned off. Nope, seems unable to switch to any higher voltage. Let's try the Baseus one again. 20 volts. But it's limited to 60 amp or 60 watts. It could be that the exact charging mode that this laptop wants, the Baseus can't provide for some reason. Although officially it should be able to, but let's try the other port. 20 volts. 60 watts. Okay. No, this should be able to do USB-C 1 and 2 output 20 volts 5 amps. I mean, we tested it at that also. I mean, so we know it can do that. But this guy, it's just kind of noping. Nope. Wait! I see what's going on. Look at that arrow. Look at that arrow. No, don't focus on that. Come on. There. The laptop is charging the power bank. Why? I don't want that. Maybe I flip a switch? Okay, so now it's outputting. Nope. Yeah, even without the meter, it I believe it started charging the power bank, I guess. Well, no, it doesn't, but I don't know, man. This is a bit confusing. Yeah, at least this one does 60 watts out. I mean, I guess it's a protocol that, you know, it doesn't fully support each other. That's fine. I can get that. Well, I kind of intended it to use it for my laptop, yeah. But it doesn't seem like it's gonna work. Come on. Okay, let's start up the laptop, see if that makes a difference. Just one moment. Wait, no, don't look at my super secret. Oh no, wrong codes and okay. So does it think it's plugged in? No. Of course it doesn't. Okay, let's try it again. Okay, well, before someone says, let's try the cable that came with the power bank. So that's this one. Encourage DP charging, dual port. What kind of charging are you looking for there, Savog? Okay, let's plug this into my laptop. I don't know, let's turn it on, plug it in. Nope. We can try something that's horrible, turning it around. Nope. Yeah, no. Doesn't want to do it. Okay. And if I get the other one. I'm not sure my phone actually uses PD. Well, we can try. So let's try this guy. Yeah, no problem. Oh, look at that. Yeah, 20 volt, 4.5 amps, or 4.2-ish. So I was actually liking the other one more up until now, because this one actually works. And it's doing 86 watts. That's pretty decent. Okay, okay. Same cable, same everything. let's go to this power bank. Oh, it's starting to reboot again. Now it's not doing anything. Five volts. Nope. Okay, let's try the wall charger as the last thing real quick. Yeah, immediately does it. Yeah, no problems there. Okay, wall charger perfectly fine. Well, one thing we can then now try, which you guys were asking me, is can the Baseus do output to the laptop? Oh. While also doing input. Can I get 2 meters in here? Okay, I can't get 2 meters in here, but I can read out from the wall socket how much is drawing. So that's no problem. I don't know, let's where's my USB-C cable? Here it is. Yeah, so this one isn't perfect either, because indeed it doesn't know what it wants to do. Of course, now that the laptop is on, it does seem to settle at the higher rates. So, okay, let's plug this one in next to it. Okay, restart it. So it says 44 watts, but it's not doing output anymore. Hold on. I think I've pressed too many buttons. There we go. So it's charging with 44 watts or 20 volts, 2.2 amps. That is about correct. And it takes 39 minutes to fill up. But there's no output anymore. Let me pull this out. Plug it back in. So it does give 20 volt out. But no, it doesn't deliver any current. So let's disconnect that. And immediately it starts delivering current. Okay, let's reverse it. Let's put it on in out 2. Okay, starts delivering current, no problem. Yeah, 86 watts, excellent. And then let's plug this one in. No, it starts charging the device, but no output. Yeah. Oh, but when I disconnect it, the output does rise. So now we're at 65 watt. And if I plug it back in, it goes to 34, 44. But it might be because the output is now pinning the voltage somehow. Yeah. Yeah, and once I pull it out, it charges with 65 watts. Okay. Let me close my laptop because I want to see if I now plug in the laptop with it closed, if it goes back to that 60 or 65 watts again. Because that might be a behavior of the laptop with certain chargers. I don't know. So let's plug that in again. Oh, now it's up to 90 watts. I don't know, man. The behavior of this thing is kind of sketchy, as in you don't know what it's going to do. But it's at least a lot better than where is it? Then this one, which basically does not want to charge my laptop. Nope. Yeah, it just refuses to charge my laptop. Okay, let's plug in my phone. Well, let's plug in my testing phone I have over here with the IR camera. Okay. 5 volts. 9 volts. Okay, 9 volts, 2 amps. 2.2, 2.3, 2.4. Oh, the voltage is also rising. 26 watts. 27 watts. Huh. See that? It does perfectly fine. Let's try the other one. Yeah, seems to be behaving about the same. Yep, 27 watts. Let's try the wall charger just to be sure. The wall charger actually isn't switching to a higher voltage. It's switching to a higher amperage. Interesting. Okay, must use a protocol, I don't know. No, this phone, let me check my own phone. But those, that one isn't the fast. This is a Galaxy S 20. Super fast charging, okay. Sure, that does about what I expect. So that was the wall charger. Let's try the Baseus. Super fast charging. Oh. Yeah, but this phone is 2.5 years old. I mean, newer phones will go much faster. This one actually does a little bit less, 12 point something. Okay. And now let's try this guy. Super fast charging. No, this one does not do USB PD yet. So this is quick charge or whatever, yeah. Yeah, that's about right. Maybe it's even faster using the USB-A port. Do I have a USB-A cable here? Yeah. Oh, now it's only fast charging. But fast charging is about the same speed. I don't know, man. Ultimate super fast turbocharging, yes. Okay. Let's try the USB-A ports of the other. Of this guy. Fast charging. It might be when my phone is a lower charge because it's already at 81%. That super fast charging goes up to 24 watts, maybe. Connect 2 ports of the power bank together and see what happens. Yeah, but maybe you can have perfect ultimate. Hey, it's better than ultimate because it's the perfect ultimate. I don't know. Okay. Yeah, we wanna hook them up together, see what happens, see who wins. Sure. Let me remove my laptop. And my phone. So okay. Let's do USB-C to USB-C to make it fun. So we're going in out on one here, and let's go in out on this guy also. Nope, they're like, yo, who's gonna do what? Oh, okay, this one won. It's now getting, oh yeah, there it goes, it's ramping up. Yep. The Baseus is currently charging this one, the what's it called again? The AOHI with 100 watts. Hey, Dradstal. Cool. Now let me reverse these plugs, because I've always wondered about that, if that makes a difference. So they're fighting a little bit, who gets to do what. And then this guy wins. He's like, no. Give me all the power. All the power is mine. You will charge me. But that's also kind of what we saw with the laptop, where the laptop was charging this guy. Yeah, exactly, Patrick. Huh. Oh, wow. Yeah, we're at 110 watt according to this plug. Damn. This power bank is very needy. Yeah? Yeah, you could say that. Maybe... I don't know, maybe holding the button does something? Nope, still fighting. Nope. It's going in here. Now, one of the things I wanted to check is an annoying behavior some power banks have, and I kind of get it, but they shut off during low wattage loads. So if only like, I don't know, like a 50 milliamp is being drawn, they'll actually shut off after like a minute or two, which I hate. So let me see if I can test that with the tester. So let's plug this in. Let's plug that in. And that's not doing anything. Can I turn it on? See, it's not getting... It's not like, hey, you want power? No. So I have to start with a draw. So now it's asking for 100 milliamps. Okay, it's not enough. 200 milliamps. Nope. Okay, 500 milliamps. Let's turn it on. See, it doesn't want to turn on. Let's try the other one. Nope. And this power bank. Wait, did I bodge it up? Let me remove the meter. It just doesn't want to start. I don't get these things. Because if you plug it into a wall charger, nothing happens. Okay, something's wrong with my test setup here. What's going on? Let's turn this off. What? Is this cable now broken? Okay, try a different cable. I don't know. Welcome to the wondrous world of testing, where nothing goes as you expect. Okay, different cable. Nothing. What? Oh, this is the wall thingy. Give me power. What, the wall thing? No, it's not doing anything. It's just refusing to get 5 volts. Yeah, I can have the meter do that for me. No, actually, this makes sense. Sorry. Philip is right, actually. This is USB-C. And if the device on the other end is not properly USB-C, it won't even provide 5 volt. So if I flip this switch, now the meter does it for the device, and then it works. But if I replace this for USB-A, then it immediately works. So USB-A in the specifications always starts with delivering 5 volt. So yeah, USB, there we go. Let's go plug this in. 5 volt always. Doesn't matter if the tester is on or off or whatever. If you plug it in, you get 5 volts. Okay. But if you have a improperly built USB-C device, you plug in USB-C, you plug in USB-C, and then it seems broken. But it's actually working just fine and adhering to the USB-C standard. Because you need 2 little resistors at least to have USB-C turn on. So actually, the power banks and everything here are doing that because the negotiation isn't happening. That's good. And before I tricked that using my little meter here. So, I mean, also from this guy, I'm willing to bet if I plug in USB-A to USB-C, instant 5 volts, no problem, right? And then the other power bank, instant 5 volt, no problem. So actually, the charger and all these power banks are delivering USB-C in the correct way. If there's no negotiation to ask for power, it doesn't deliver power. That's how USB-C works. So even if we have, let's get a different example here. This is a dig to go. Let's connect the LED strip real quick. I mean, I know this stuff because I had the design for it. And let's get random USB-C to USB-C cable. The one with the meter in it. That's nice. So, random USB-C port. Oh, let's get the right end here. To dig to go USB-C. And it turns on and works great. That's because the dig to go adheres to the USB-C standards. Yep, button works. Nice. Okay. So that was my fault. I kind of forgot that. If you do not negotiate power over USB-C, you're not getting any power. That's just how it works. That's fine. Okay. So, do we have any conclusions? Before we go to the secret? I need a drink before I go to the secret, that's for sure. Are we going to do cherry or vanilla? I want cherry. Never mind. It's not a question anymore. I'm doing cherry. Oh, yeah, that's right. That's right, Johnny. We'll resume that in a minute. Well, I'll resume that now while we're talking. But instead of using a USB-C to USB-C cable, I'll use a USB-A to USB-C cable because a USB-A port doesn't need those negotiations. A USB-C port does. So, yeah. But at least we verified that it's working by design, which is good. Okay, I started a 100 milliamp load on this guy and see if it stays on. I don't know, 1 watt? Or it's actually 0.5 watt. Actually, I lowered it to 50 milliamps. So we're testing 50 milliamps power draw, and let's see if it does that for a little while. That's a good question, Patrick. But most often, this happens when you're like charging a remote or something like earbuds or things like that, which draw very little power. And then the power bank will be like, oh, well, I don't think anything's happening. So, yeah. $20 milliamp. Okay. Okay, I've lowered it to 20 milliamp, Johnny. That's 0.1 watts. Why all earbuds come with a battery case? Maybe. Oh. It shut off. So let me raise that to 30 milliamps. Nope. Doesn't turn on. Doesn't turn on. Oh wait, you can't see. So it shut off. Test off. Test on. No, it's not getting any voltage anymore either. So okay, turn it on. Let's go back to 20 milliamp. And let's keep drawing that. Nope. It's not drawing anything. Oh, okay, sorry. Turn the tester off. No, it's not doing it. Okay, there we go. 20 milliamp. Yeah, okay. So it's drawing 20 milliamp. Yeah, I get that, Maiko. Yeah. Yep, there it went. Turned off. Okay, so this one kind of fails that test. Let's go to the Baseus one. Yeah, okay, it's drawing 20 milliamp. So, who knows what I'm going to show you in a minute. What would use 20 milliamp? I don't know, actually, Philip, but I've had issues in the past, even just running like an ESP32 or an ESP8266 on a power bank. Oh, there it went. It's off. Yeah. Okay, so let's try 50 milliamp. Of course, now it won't do that. Maybe I have to reinsert it. Yep. Philip and Johnny both know what's coming. That is true. Are there any LED enthusiasts here in the chat? I know we're only with 50 people today, but... Oh. There it went. Turned off. Let's go to 100 milliamp. But I believe one of these power banks actually should have a mode where it stays on. I read something about that. Go away, pop-ups. Still on at 100 milliamp. I'm just looking up the pages right now. Still doing 100 milliamp. Okay, so I don't think it's the AOHI. Let's check the Baseus. $100 milliamp still going. Well, the Baseus does indeed list that it has an NTC temperature sensor intelligently monitors temperature of the circuits. Oh. But where? I thought I ordered also one with a low power mode. Can't find it. Okay. Well, 100 milliamp seems to work. That's good. But what we can actually do is hook up the dig to go. Because that's not going to use a lot of power. Let's add the little meter in front of it. Because the dig-to-go is actually very power efficient. Oh, okay, well, let's turn this off. No, it doesn't matter if there's no LEDs on there. It's still drawing 160 milliamps, and we already established that with 100 milliamps the power bank stays on. So even with a draw of 0.8 watts, it does, well, the power bank will keep doing that. And it's able to do that for 28 hours. Cool. Will it also show me how long I can run my LEDs? So LEDs are on. We're drawing about 2 amps from the 40 LEDs, 5 volt. Well, we're getting a little bit of voltage drop because this is now at the end of the cable. And I'm able to run these LEDs for 3 hours and a few minutes. I wonder what will happen if I give it a much more varying pattern. Hold on, just need to log into my router real quick. Log. Okay, yep, that's the correct W instance. And, well, we can put it on audio reactive mode, but we already showed you this last time. So let's put it on color twinkles, I guess. Yeah, that kind of varies the power a little bit. Maybe color waves? No. Color loop? No. Okay, this very much varies the power. Oh, a Twiki, okay. I did that so that the music would be there if I wasn't talking and would come back when I stopped talking. But, okay. You're one of the first telling me that's annoying, so interesting. So let's see how long this lasts. Oh, well, it can do this for like 10 hours or so. Nice. And it's only 52% charged. So... No, well, I mean, I like the music, but I can make it so you guys don't hear it, but I kind of like having some background music on the stream. It shouldn't be overpowering, though, but a little bit of background music. But, you know, it's interesting feedback. So, yeah, this is I like the little display here. So, if I change the pattern, does it then also give me a different estimate? So, let's go to palette. And, you know, let's up the power a little bit. Yeah, so now we're drawing more, and the estimate adjusted just fine. Maiko doesn't even hear the music anymore. I don't know about that, Patrick, but I do like the little display. And it seems to adjust well enough with the estimate. So if you're using this to have portable LEDs with a dig-to-go... Oh, I actually wonder about that. So let's turn it off. So we're now drawing 0.8 watts. Okay. I wonder if it's different if we use USB-C to USB-C. It shouldn't be, but... So I guess I already verified this, of course, but I guess this verifies that my Dig2Go is also a proper USB-C device. So, okay, we're drawing 1.8 amps or something like that. We're drawing a higher voltage. That's interesting. Let's turn it off. Yeah, 0.8. It's about the same. Okay. Tycho, check my video history. A little while back, I did one that can do at least 65 watt, or I believe even 100 watt in the car. I've been using that one ever since, and that's been working fine. So, yeah. Okay, well, enough about this. I'm not sure what the current conclusions are for these two power banks. So far, the Baseus seems to be doing well enough. It at least delivers 3 amps, and most often will also deliver 5 amp to my laptop, and it also did it most often to the load and things like that. So I think the Baseus one I can likely recommend. Quality-wise, it's decent enough for sure, and I really like the little display. It's not cheap. It's not cheap, but it does what it says on the box, so that's good. They're a bit all over the place. 60 people waiting for secrets. Yes, we're getting to that now. Okay, let me clean this up a little bit. It's kind of a mess here. There we go. More power banks and power bricks, and I have to watch out with my can of Coke. Okay, let's get these cables out of here. Okay, tester. Right, so what you've been waiting for, and what I've been waiting for to unveil since last November. Or well, I started working on this since November, and I kind of need to prepare it a little bit. Hold on. Let me just prepare this real quick while you listen to the music. Haha. So this project has been in development, as I said, since November, and it's an LED controller, kind of like the Dig Uno and Dig Quad, but then a new addition to the lineup, where with the Dig2Go that I just showed you, we're basically going down. It's a simplification of things, and it's very singular purpose. This actually goes up in things. So we have the Dig Uno, we have the Dig Quad, and now we're going to have a Dig Octa. So what this is it's going to be, and it partially already is, a system you can use to build the LED controller you need for your project. So what does it have? It has an ESP32, just like a Dig Uno or a Dig Quad, but then it also comes with Ethernet, it comes with an SD card slot, and it has 8 LED output channels. Now, this board in the system is what I call a brain board. So this does nothing in regards to power for your LEDs. So this is basically a logic controller where you can have 8 output channels and have your real-time LED data coming in using the Ethernet port, or you can have your LED data stored on your SD card, or you can have it over external Wi-Fi with an external antenna. It comes fully equipped with a USB to serial chip. It has USB-C power input, and it's basically an 8-port LED controller that's compatible with WLED and ESP pixel stick, which is able to control 8 output channels. Now, in regards to total pixel amounts, that doesn't really change that much versus the DIG Quad. So you're still limited to 2000 LEDs that you can drive in total. But this is a very much segregation of the DIG Uno and DIG Quads, which have power delivery and LED controller in one, and you have lots of different options and boards and configurations and things like that. But this is a Brainboard 32-8L, so it has an ESP32 on there, and it has 8 local output channels. Now, in the future, there's going to be different Brainboards, but they'll all have singular configuration per Brainboard. But instead of having an 8L, you could maybe have an 8R with 8 differential ports for remote LEDs and pixels instead of local LEDs and pixels. And the rest might be the same. But the idea is to make this a multi-year lived system where at some point maybe there will be a Brainboard which doesn't have an ESP32 on there, but it might have a completely different controller on there, but still provide LED output channels or some function in regards to LEDs. Now, this board can have USB-C, 2-pin power input, or a third form of power input, and I'll show you that in a minute. And all of those power inputs can be between 5 volt and 24 volt, and the board has an onboard buck regulator, which then makes it the power that this board needs. There's some extra function on there, like button inputs, there's an I2C temperature sensor, and there's external I2C. The only disadvantage of the I2C on this board is that LED 8, so channel 8, is shared with one of the pins of the I2C. So if you're using all 8 channels, you can't use I2C, but if you're only using 7 channels, you can use the I2C. No, so for PUE, you basically still have the same option as on my current controllers. I am thinking of making a future option, but currently I'd advise getting one of these PUE extractors or something like that, where you just insert your Ethernet. This Ethernet then goes in here, and then you can just put the 2-pin power. You have to snip off this connector or get a conversion block, and then you can use PUE power to power this board if you want to. And as I said, this one can be 5 volt, 12 volt, 24 volt, that's all fine. So that is a Brainboard. It's a LED controller which does nothing with power except make sure it itself has the right power. But then what do you do with power? Because you know me, I'm all about power with my DIG Uno and DIG Quads and fuses and all kinds of stuff like that. So what do? Well, that's where a power board comes in. So that's kind of what makes this a system, is that instead of having one board... Hey, unexpected maker is here. Nice. We now have multiple boards which basically stack together. So this is a DIG Octa system power board, and this specifically is the Power 5. It has 3 input fuses because you're able to connect 3 input wires. And then this Power 5 has 12 output connectors for the 5.08 millimeter style pluggable connector like these. And you can use one or multiple of these in the controller you're building for that time. Because all ports are on the side and they plug in from the sides. If you then say, okay, but I want to, I don't have one here right now. Hold on, I need to unscrew more stuff. Just 1 second. Nope, that didn't want to go. Dig Sep2 with I squared C? No. Okay. One moment more. I need to unscrew a few more things. Good night, Maiko. Almost there. Few standoffs left. I guess I should have started unscrewing, huh? Oh, we got a spammer. Thanks, Johnny. Okay, done. So, we had a Power 5 here, and these are all still prototype boards. I'll be getting the pre-production boards next week, on which me and some other folks will be doing testing, and then I'm hoping to release this very soon. So, this is another Power 5, and the idea is that you can use these kind of standoffs, well, not right now because this one's screwed in, but you can basically stack these together if you need more power ports for that particular controller. So now with the brain board and the power boards, if you need more LED channels or more LED driving power, you just add brain boards. And if you need more power ports or power in total, you just add more power boards. So for instance, you could build a controller which has 2 Power 5s, that gives you 24 power ports, which can do 5 to 10 amps each, and then you can use 1 or 2 brain boards on top of that. Because the idea of the whole system is, I guess I'll show you on this version. This is a slightly modified version of a third power board. But the idea of the whole system is that you have these metal standoffs on which basically the controller goes on top and becomes, well, one whole basically, forming a LED controller with data ports and power ports. Actually, no. That's been designed into the system. So if the... Oh, yeah, okay. If you have 2 Power 5s on top of each other, it's probably advisable to use 3 centimeter standoffs, and then you can still reach the fuses in between the boards, basically. But other than that, yeah, it can be an issue getting to the right fuse. One of the features the power board does have, it has a fuse broken indicator per port. And once I show you the pre-production boards in working order, basically, I'll show off all those features. But you get an LED light for a broken fuse, so you know exactly which port has a broken fuse. But the idea is that you stack on everything. You stack on power boards and you stack on brain boards, just like that. And if you want to run multiple brain boards, that is also supported. So you just stack another one on top of there. You can reach connections on this side. All connections on this side are pluggable. So you can just, I guess you could infinitely stack, but that's not really the idea. You can use several of each to build the controller for that box or that spot you're working on currently. And there's a secret feature, I guess you could call it, and that is that a power board will actually supply power to a brain board using these standoffs. So if you put 5 volt 12 volt or 24 volt on a power board for your 5 volt, 12 volt or 24 volt LEDs, and you then stack on a brain board to really make it one controller as a whole, the power board shares its power with the brain board. Yes, there's polyfuses and diodes and everything in there. It's basically impossible to F up. The worst thing that will happen is that it won't turn on. And also, I guess I can talk about this guy. We're not going to sell this configuration immediately, but I have made all the power boards PTC compatible. So this, for instance, is a Power 7. A Power 7 is different than the Power 5. Let me talk about a Power 7 real quick. Yeah. So first I showed you the Power 5, which had 12 of these pluggable connectors, right? This is a Power 7, and a Power 7 is different in a few regards. The Power 5 has plus and minus on each of the plugs, but the Power 7 has islands where this is all plus and this is all minus. That has to do with distributing the power and stuff like that. Yeah, 24 volts safe to touch, but even anything you can short is fused or double fused on here. So even if you could feel it and short it out completely, in theory it can never go wrong. So the Power 7 has bigger screw terminals than the Power 5, because this can take 16 to 14 gauge with ferrules on there, and this guy can take 12 gauge with ferrules on there. Or there is a special double up feature, and I'll talk more about this in future real videos, where you can actually hook up 8 or 10 gauge to it using 2 terminals at the same time. So you can get giant cables in there with lots of current, and this one is very interesting if you're building a single controller which has 8 ports and you need 8 power ports plus 8 injection ports. Well, this gives you 16 terminals and thus giving you a lot of power. It tastes bad though. Holy shit. Oh, camera died. Oh no. Huh. Guess I went too long, huh? Let me get a battery. Sorry about that. One moment, please. I'm back, but I still need to put the battery in there. Just one moment. There we are. Hello. Well, that was stupid. I still need to fix that at some point. I don't know where I was in my story, and my story was kind of all over the place anyway. So yeah, there's going to be different types of power boards which are suited for different types of purposes. The Power 5 is built to easily stack very well because all connections are basically on the outside. The Power 7 is a denser power board, which pairs really nice with 1 or 2 brain boards on top of there, making a very nice and compact controller with lots of ports and lots of power. Both the Power 5 and the Power 7 are able to handle 50 amps continuous in total. But I've heard the haters, and the haters are like, 50 amps, 30 amps, what's this guy talking about? I need 100 amps. I got you with your 100 amps. This is a Power 7 HC, standing for high current. And this board is rated for up to 100 amps continuous. So if you pair this with one of those, remember those LRS 600 power supplies you were testing from Meanwell? Exactly. That will do 5 volt, 100 amps into this power board. It then has 2 60 amp input fuses, and then you're able to distribute the power to 16 output ports of 100 amps in total. Each port is allowed to do 10 amps, or you can use the double up feature to go to 20 amps for a single cable. So 100 amps. Yeah, this board is definitely crazy. You need, especially if you're running at 5 volt or even 12 volt, the amps stay the same. You're gonna need some thick cables there. 100 amps. Now I can make my 5 volt welder project. I don't know about that. Yeah, well, there's some crazy copper in here. And these are prototypes. This prototype is 4x1 OZ, but for the actual production boards, we're going even more copper. Yeah. So this also has a price, of course. So the normal Power 7 version versus the high current version will, of course, be cheaper. And, well, they all have their own price in regards to components and complexity to assemble and stuff like that. But yeah, this is the new system, and I did a really bad job explaining all the features and why all of this makes sense. But the biggest thing you need to remember right now is that the DIG Octa sits above a DIG Quad, and it basically is a system where you have separate controller brain boards, like this guy, and separate power boards to do the power distribution. Each of these can work independently, so if you just need power distribution, you can get one of those power boards for whatever purpose you're planning to use it for. Or if you just need LED channels with properly level shifted and resistors with Ethernet input and ESP on there, you can get a brain board. But the real power of the system is once you combine those and it basically forms one controller you can use to do your LED project for data and power. So yeah, that's what I've been working on since last November, and it's almost here. You'll be seeing a lot more about this in the coming weeks, and I'm hoping to release this in the beginning of September. We might do pre-orders. I'm not certain about that yet. But this has everything in there, which I think really elevates this to a next level system. As I said, the broken fuse and the indicators per output and or per fuse. It has a voltage display. It even has a little capacitor and reverse polarity protection per output port, and massive amounts of power distribution and voltage power planes and things like that. And there's a lot of engineering and testing that's gone into these things. I mean, remember when we were testing this board during the stream, or this board? We did a lot of fuse testing on this board. That was all because I was designing this stuff in the background, and I needed to test it to know how to design it. So that's why I made testing boards with all kinds of different configurations to do all kinds of testing which has now accumulated into the Dig Octa system. Oh, I don't know about that. I haven't checked the PCB on my LRS 600. So yeah, even Brainboard, I guess we can build a little stack here. How about we build a stack with 2 Power 5s and then 2 Brainboards, I guess. I should have all the things I need here. Yeah, the fuse lights are very nice, I think, too. And they work really well. I made them nice and bright, so you can see which fuse filled on which fuse exactly. I experimented a little bit with transparent connectors, where the connector would actually glow to show which port had a broken fuse. But in the end, getting all those custom transparent connectors and things like that, I mean, it's a nice feature to have, but no one's going to pay like $20 extra to have the connector glow instead of an LED next to the connector. So that didn't make it into the final version. So okay, let's see here. We have two Power 5s. Let's stack those together. So what we want to have, since we're making a desktop model, we want to have little feet on the bottom. So we're going to use little feet standoffs. Yeah, connector glow for the win. Yeah, for sure. But it was way too expensive. And I'm just gonna, the way this works is we're just gonna thread standoffs into each other, basically. Now these are, I believe, 4 centimeter standoffs. Maybe a bit too high, maybe a bit too low. I'm not yet fully done deciding what length all the standoffs should be. But as you can see, the process of building this up is very easy. And you can also imagine that this bottom standoff, for instance, this one could be in a building plate or in whatever, or they could be mounting holes where you screw this into, and then you basically screw the board on top of that so you can have a very secure mount. Collectorless edition, yeah. So to stack it, you basically just put it on top and then screw it down. But we don't only... Oh, wait. Wrong way around. Wouldn't have broken anything, but we don't only need power. We also need data, or we want data. So let me whip off this antenna real quick. There we go. So we're also going to put standoffs for the brain board on there, and I need 5 screws for the bottom for that, because as Philip mentioned earlier, there is let's see what length I'll make these. Yeah, that's not long enough. There are 4 ground standoffs and 1 positive standoff. I don't have the right standoffs here. How did that happen? Because they're on here. I need to do more screwing, sorry. Pink fuses! No. I really wish I could do one-off editions like that, but they'd cost... I mean, the pre-production batch, which has more boards in it so that a few other people can test it too, that costed me a few $1,000s just to have it made. Because boards are cheap if you make them 1,000 or 2,000 pieces, but if you make 10 or 20 of them, they're not as expensive, but per board they exponentially grow in price. So instead of paying like $10 for a big PCB like this, you're paying like $30 or $40 a piece. So yeah, that is a lot. So to stack the brain board, as I said, there's 4 connectors, or 5 spots, sorry. And those are not M3 like the other ones. They are M2.5 to make sure there's a difference in there. You build the boards for me. You can't even get the materials for 2K. So that's going to be interesting. But Patreon limited edition crowdfunded. Yeah, I don't know, man. I have a hard enough time getting the real edition out. But we're getting there soon. In my testing, all the boards now work basically perfectly. So I'm going to have some other people verify that. It's always a smart thing to do. So I put some standoffs on here. These are kind of too tall, but they're the same length as the power board standoff. That's not going to work. I'm an idiot. Sorry. See, I still need time to figure this all out myself. The standoffs for your brain board need to go on the top board, not the bottom board. Roger, that's correct. If you have a power board in your stack, as long as the power board has power, so let's put this on top here. As long as the power board has power, it will also power the brain boards on top. Now there are limits to that, of course, and those will be listed in an article. I've been working on these articles day and night already. But generally, let's say if you have 5 volt, you should be able to run 3 power boards, 3 brain boards on top of a single power board. Yes, actually VXT is much improved, because if you look at this brain board, you have the power stack feature, or Q power pole or whatever, that is coming, Q power post I think I dubbed it in the end. That is coming in. That is one way to power the boards. Then you have this 2-pin connector that powers the boards. And you have USB-C. And all of those can be connected at the same time. And all of those can have different voltages if you wanted to. So even if you have 12 volt LEDs, the brain board will send, or the power board will send 12 volt to the brain board, and that will power the brain board. That's fine. But if you then want to have standby power for the brain boards when you turn off your big power supply with a relay, and there is a dedicated relay on each of the brain boards, relay output, that's fine. You can use the USB-C input to provide standby power, while the relay output turns off your 12 volt or 24 volt power supply, and all of that is connected at the same time without any issues. So this needs to go on here, and I'll talk about it in a second. No. Actually, that is correct, but basically, if you're screwing in a brain board into a... Sorry, if you're screwing a power board into a base, you basically wouldn't connect the stacking pins for the brain board. And just like I did over here, and I'll show you right now, if you look at the bottom, you see these 4 outer pins. Those are all ground, so there's no positive there. The only positive stacking pin that exists is this guy over here. But if you look closely to here, if you see the top board now has the pins or the stacks, the stacking whatever, to put the brain board on, but that is screwed into the bottom, so that never makes contact. So even if it would have been on this bottom one, as long as you had these little standoffs here, which raise the board up a little bit, if there would be a screw in here, which is positive, that still doesn't make contact with anything. And even this guy, I've made it so that you can put it on this way, which is the way it's supposed to go with the cutout, and you can still reach the power terminals and things like that. But even if you put it on this way, there's no problem, because positive is still positive and negative still negative. And even you could even put it on this way, I guess. Doesn't matter. It's all still what it's supposed to be. There's no way to do it wrong, because it always lines up and it's always correct. So if you wanted to do it this way, okay, that's fine. You can do that. So let's screw this guy in. Or did we also want to make a brainboard stack? I guess we can make a brainboard stack too, huh? Just build this Insano configuration. And maybe you don't want to share power. That's fine. I don't know why not, but I guess as long as you don't connect the middle one, there's no power being shared. Yeah, go big or go home. Yeah, I actually don't have enough prototypes. These are all various stages of prototypes boards, so they don't represent what it looked like in the end, but close enough for now. Okay, and let's put on another brain board. Well, exactly, Tim. That's exactly the idea here. Configure it the way you need it for that box or that setup or situation you're building, and design or configure the controller boards as you want them. In a lot of controller boards out there, if you want to do power injection, you're actually giving up data ports because they're all shared. I already did that differently on the Dig Quad, where you have separate power ports and separate data ports, but it was still on one board, of course. And this actually separates that too, where you have separate power boards and separate brain boards for the data ports, and thus you can build it whatever way you need it. Yeah, relays are built in. This port here is a dedicated relay port, which always outputs 5 volt on the power pins and on the data pins. So even if you're inputting 12 volt using a brain board, the relay output still outputs 5 volt positive, ground, and 5 volt relay trigger, or 512 volts. So each brain board can have a separate relay, and the circuit is also very different than it is on a Dig Quad, where it's basically MOSFET controlled. So instead of having a level shifter or something like that, which really isn't designed for it, you can easily hook up 2 or 4 relays to a single relay trigger if you want to, and that'll work fine. Or you can have multiple brain boards which each have their own relay trigger. So as you can see here, in the end these ports will actually be orange, and the plugs will also. And there's going to be many differences. This still has flat head screws, which I don't like. There we go. So this has flat head screws. I don't like that. So this was actually one I got to test. So these have cross-shaped or Phillips head screws, which is much better. Same for these. Same on my power boards. These terminals all had flat head screws. I don't like flat head screws, so in production everything's going to have Phillips or cross screws. So close look at the brain board. Sure, you can also use a relay to trigger multiple relays, but there's a strong relay trigger on there. That's basically the idea. So now you can see here how this lines up. You can easily access these ports because these are all removable connectors. You just screw in your wires and then plug it back like that. You know, Ethernet easily stacks like that. And then on this side, you have your button inputs. You have your I2C. Or your LED channels, which you just screw into these blocks, and then you can plug them in easily. And if you look here, as I said, I'm still experimenting with different heights standoffs. I believe these are 4 centimeters. The brain boards have been designed that even if a brain board is on top of a power board, I can easily still reach a fuse socket and replace that fuse. So especially if you combine it with like the Power 7, which has 16 power ports, and well, the HC version can do 100 amps. That's a lot of power. You can still reach those fuses even though the brain boards would be on top of here. No problem for that. And even this guy, this is, I believe, stacked with 3 or 4 centimeters. I don't remember from head right now. But even here, I can easily grab in and replace that fuse. Now, that is because they're power 5. If they're power 7, that doesn't really go, because the power 7, the terminal is actually higher than the fuse is. So I can't go in and grab that easily. I guess I could use a tool for that, I guess. But the power 5 has been designed fully with stacking in mind. So everything connects from the sides. So you're always able to, you know, oh, this actually has those cable clamps so you don't have to screw. I've been testing all kinds of different versions. So you can always reach the power plugs, but even if you had to, you can reach in, get the fuse out, reach in, put the fuse back, no problem. Okay? And for these, the fuse broken indicator LEDs are on the sides here. So even in a stacked configuration like this, you'll always be able to see which fuse where is broken. And you can easily replace that. No problemo. Okay? This fuse is kind of broken. Theoretically unlimited. You can... The brain boards you can stack, but there is a power share limit, and for 5 volt I'd say you can go up to 3 brain boards, and with 12 volt you can go up to, I think, 5 brain boards. I'd have to look at my calculations, because there are power limits in place, and those limit the total amount of power you can use on the brain boards. So now, even if I'd okay, so in this configuration I only stacked... Oh. There's multiple ways you can or want to do this. In this configuration, I stacked the power boards together, but I didn't add the positive stack in the middle for the brain boards for this power board to this power board. So if you want this power board to power the brain boards, it won't, because that stack in the middle is missing, right? It does have all grounds connected, but it doesn't have power connected. You can still use this plug, which is meant for that, to power one of these. That's fine. But this guy does have the positive standoff. And then if you apply power to this power board, it will apply power to this brain stack. You could also change that, adding this standoff to between these two boards also, and then either this one or this one will power the brain stack. And even better, if you have multiple power boards in your stack, each can run their own voltage. you're only allowed to have one power supply per power board, but I can make this a 5-volt power board, and I can make this a 12-volt power board, and they're all allowed to be in the same stack and even sharing all the power. That's all fine, that's all regulated, no problem. Could you do a power brain combo and then put another power brain on top? I guess if you get longer standoffs, you can build any tower you'd like. Not sure that makes sense, but you could do it, I guess. I mean, in the end, I'll probably lower these standoffs because now these are a bit high, right? There's a lot of wasted space here that we could use. And maybe these could even be a little bit lower and you could still use a fuse. Yes, if you use multiple power supplies, all grounds are automatically shared between all power and all brain boards. Tim, the idea is that I'll be releasing different types of brain boards in the future, where this guy has 8 times local output. I could also make one that has 8 times remote outputs for differential receivers and things like that. Yeah. The Tower of Power. Sure, SSR should work great too, no problem. Yeah, Earth Gamer, that's exactly why I think there is a market or a place for this system. This allows you to scale power and data ports and data or pixel amount power, because even though this has 8 ports, it's not more powerful than a DIG quad. So even though this has 8 ports, it won't drive 8,000 LEDs. If we're looking at WLED, you're likely still limited to about 2,000 LEDs, just like a DIG quad is. But it does allow for more versatility, because if you now want to drive 100 LEDs on 8 ports separately, so that makes 800 in total. Let's say you have 8 props that have 100 LEDs in them. You now have the 8 ports to do that, where on a DIG quad you don't, and you'd have to string those, and etc, etc. And the idea is, even though a single brain board is limited, if you need more pixel processing power, you just add more brain boards. And that's also going to be the thing of this system. One of these brain boards isn't going to cost you a few $100 like competitor boards do. Now, competitor boards might be able to drive 16,000 or 32,000 LEDs, and these might only get you 2,000 to 3,000 LEDs at the frame rate you want. But then just get 2 or 3, and then you're still not even near the price of the other boards, and you can still run WLED or ESP Pixel Stick and use all the stuff you want. There's still testing and software optimizations going on with that, Philip. But currently it looks like ESP Pixel Stick will be able to do about 3,000 LEDs per board if you're using the SD card feature with 42 or 45 FPS or something like that. But there's always going to be limits which are lower than the amount of ports you have, basically. So that's a thing to keep in mind. But that's also why it's been designed. You then just add controller boards. And since all of them will have Ethernet and SD card, as long as they're in your show in X-Lights, doesn't matter if you have one controller with 48 ports, or if you have 3 controllers with 8 ports that can do 2,000 LEDs in total. So you just divide it over the ports, and then you also divide it in X-Lights. I mean, that's the whole idea. So yeah, this is the first time really talking about this project, and there will be better scripted videos. But yeah, this is what I've been working on since, I don't know, last year November. And as I said, oh, the spammer is back. Ethernet crossover between the boards. I guess you could do that. I don't know. It kind of looks ridiculous like this. And as I said, the heights for the standoff still need to be determined. Right now, this makes it very easy to get the fuses in and out if you want to. But in the end, generally that's not needed that often. But yeah. Yeah, the ESP32 would run out of grunt. That's true. Yeah. Would it work to only have one SD card and 3 brain boards connected to a switch? No. No, then you'd have to have an SD card per controller board. Can you use X-Lights on the DIG quad? Yeah, for sure. Well, not X-Lights itself, but you can send it E131 data over the network, or either Wi-Fi or Ethernet. Yeah, the brain board needs direct access to the SD card, yeah. But you can just upload it through the network, that's no problem. WLED currently does not support SD cards. That is correct. But ESP Pixel Stick does. And, well, the developer is also getting these boards, and he's been working on with the DIG Quad and the AE Plus and stuff like that. So, yeah. So the secret is out. I don't know. I don't know if I feel better, Philip. It's, maybe once people understand the system and it makes sense to them too, maybe buy a few. Then I'll be happy. But, you know, we'll see. We'll see. No WLED logos on the board. Well, actually, these boards are all prototypes. But I don't actually know if I'll put them on the production boards. We'll see. So, yeah. I can show you with my face in the shot. So, here it is. So, on this side, we have the... where is it? There. The input power ports. And the LAN connections and stuff like that, and all the output ports are on the other side. So we have the 8x LED connections, all the power connections. Yeah. Yeah, but Emil Bart, you're still going to run into processing limits of the ESP32. A Quinled power box to mount this into. Oh, I don't know about that. People are very adept at building those themselves. This is just going to make it a whole lot easier, because you just need 4 mounting holes for these 4 standoffs, which you then screw into that, and then you screw the rest of the board into there, and done. The board is mounted. So power supplies. No, I think I'll leave power supplies to Meanwell. They do quite well. So yeah, soon I'll be receiving the pre-production boards, which will also have the final colors, and they're going to look a lot better than this stuff. And I'll finalize what standoffs we're going to be using and things like that, because this kind of looks stupid right now being so high. It doesn't need to be that high. Yeah, it's going to be interesting times. And I just hope other people, just like with the DIG Uno and DIG Quad, understand what the system is about. And there will be people, I know, who will fall over like, hey, but a Cult board or a Falcon board can drive 800 LEDs per port and then do 32 ports without slowing down and blah, blah, blah. That is absolutely true. And this can't. And this won't. But it doesn't need to. Because price-wise, you're still going to come out ahead. And how often do you need 10,000 LEDs in a single spot? Or do you maybe have multiple spots and then you can get them closer, which you need to do for the data wires anyway? Sure, you can use differentials, things like that, but I think there's a debate to be had there, so we'll see how that goes. Sure, Emil Bart, but then you'd run an Ethernet cable to that spot and you'd still have power on that spot. Okay, but why not run a Ethernet cable with Ethernet or network on it then and have a board right there? You're going to need a box at that point anyway, which does the power. So, I don't know. But we'll, I saw the MCH sign, the way that was built, yeah, I think we can do better than that. It kind of worked most of the time. No, I didn't have a lot of pixels. It was only a few hundred. Like 200, maybe 300. And I mean, in this case, you could have each letter be its own output port. And then you could run two power wires there from the power boards. Done. But yeah. Anyway. Oh yeah, that could be built with more pixels. Sure. For sure. So, I hope people like the stream testing the power banks and things like that. It was fun for me not having to deal with stupid crashing and hanging video editing software, which really ruined my day. And I finally got to show off my system. If you're watching this after the live show, let me know down in the comments what you think, because it's always scary to dump a lot of money and time, basically almost a year's worth of time, into designing and getting this built. Let me know what you think in the comments. Can you repeat what the beast of a board is for the people who joined late? This is basically the DIG octa system. So it's a step up from the DIG quad, and it separates data outputs and power outputs into separate boards, and you can scale each as needed for your current project. That's in a nutshell. Sure, Yako. I mean, that's the DIG Uno and DIG Quad aren't going anywhere. And yeah, we still have the DIG to go, which will make a lot of other projects very easy to do. If you only have a few hundred LEDs, 5-volt power, USB-C, done. You saw earlier on the stream how easy it is to plug in and use. Yeah, but it's very different. I mean, the purpose is very different between these two. What do you mean with the two Ethernet ports, Michael? Basically build in a switch? I did look into that, and I have some plans for that in the future. But currently there wouldn't be enough space on a brain board to put on two switch ports, or it would have to be a lot bigger and also become more expensive. Yeah, but that would make every board more expensive, also the people who don't use that. So currently, if you want to run like 3 or 4 brain boards, just add a $5 or $10 100 Mbit switch into the same box and you're done. Can I play Doom on it? Can you play Doom on an ESP32? Because then you can. Yeah, no, I mean, for a Falcon, I think it makes sense because they're in a different price bracket. For your understanding, let's say you wanted to buy a Power 7 and 2 brain boards. I'm trying to target that still under $100. Now, that is more expensive than a DIG Quad, but if you need the amount of ports and data and Ethernet and stuff like that, it quickly becomes relatively the same price, and versus a Cult board or a Falcon board or stuff like that, those often, the beagle bone you need plus the license for FPP, you're already looking at $100, and then it still doesn't include the actual pixel driving hardware. So I think there's a price point which this makes sense in, and different configurations will come down to different prices. In the end, we're going to sell each component separately, but we also might make a few kits basically that you can buy, which come, well, they don't come pre-assembled, but well, everything becomes pre-assembled. This is no DIY, but you'll still have to build the stack yourself. But that's just screwing in a few standoffs and posts, and I'll have detailed picture guides and stuff like that for that. So yeah, they changed that. I think 2 weeks ago, Michael. So now all FPP, if you want to drive more than 50 pixels per output, you'll have to pay. I'll look into pre-orders. I'm not certain about that yet. So, we've been going for 3 hours, and I'm getting a bit tired. So we're going to round off the stream. I thank everyone who was here doing some fun power bank testing with me, and, well, looking at the Dig Octa together. And, yeah, thanks for watching. Catch you in the next video. If I can ever get one rendered, but we'll see about that. Okay, bye-bye.
Talk about another kind of world. Another kind of world.
What are you afraid of?
I'm lost in old ways.
I'm not afraid.
Well, here goes nothing.